I'm Miss Delv and I'm one of the new teachers here in room 1, and today I'm going to be walking you through the math curriculum that we have in Montessori. So we first start off with the numbers to 10 section, and a lot of the 3-year-olds do come into the classroom already knowing the numbers just from being at home, but we like to go through all these exercises just to make sure that they know and they can see and feel the difference between 1 and 2 all the way up to 9. When they're really holding all 9 of those spindles in their hands, they can really feel how big 9 is compared to 1. And this is also where we introduce 0 to them, which we cover throughout the math unit, but this is when we first introduce the fact that 0 means nothing. After they learn the numbers up to 10, then we move on to the decimal system. So here we have a single bead, which we call a unit or a 1. And then we have a string of 10s, and we have the children count how many units are in the 10, and they find out that there are 10 units in a 10. Then we introduce them to the 100, and they also count how many 10s are in the 100, and again, there's 10 10s in a 100. And after the 100, they go on to the 1,000, and they count how many hundreds are in the 1,000, and they learn that there are 10 hundreds in a 1,000. Lots of the materials in Montessori use the base of 10, so such as the pink tower, all the cubes are a unit of 10 and they get smaller, the same scale. So then after they learn the terminology for thousands, hundreds, tens, and units, they go on to making numbers. So for example, 3,512 is made out of 3 thousands, 5 hundreds, 1 10, and then 2 units. So when you look at the number 3,512, it looks pretty intimidating, but when you put it into the context of just thousands, hundreds, tens, and ones, the foundational math that they have in their head really sets them up for success when they go on to higher math concepts. Then after they learn the decimal system, they learn to count to 1,000, and that's where they see how numbers change between each of the numbers and between the different categories. So for example, we have 49, and after 49 comes 50. So after all of their work that they do in the decimal system, they'll recognize that when we have 10 units, that those can get changed out for a string of 10, and 49 then becomes 50. So it's very magical seeing, even as an adult. I can only imagine how exciting it is to see it through the eyes of a 4 or 5-year-old. Then after they have lots and lots of practice counting up to 1,000, they move on to the exploration and memorization of tables. So that's really just a lot of work doing all of the different math units, so addition, subtraction, multiplication, and division, and they just go through, they use these booklets that have all of the tables from 1 to 9, and they use different boards, and they just repeat, 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 so that in their brains that they have those tables memorized, and then when they go on to the passage to abstraction unit, when we ask them, hey, what's 9 plus 8? They already automatically know that it's 17. And when they're doing their work with the passage to abstraction materials, such as the small number frame, small bead frame, they will do things such as multiplication or even division, and they'll just already magically know the answer in their head before doing their work on the material. And that's pretty much just a brief explanation of how we can have a 5 to 6-year-old do even long division.